Okay, students, now I hope you understood what is the reflection under x-axis, what is the reflection under y-axis, and then now it's time to learn something called as reflection under origin. So in this part of the video, we're going to see what is the reflection under x-axis, y-axis, origin, double reflection, invariant point, all the concepts we're going to finish up in this particular video. So I hope you are excited. Let's come back and see how to do all that thing. So reflection under origin. What do you mean by reflection under origin? This is second video guys in the reflection. So please watch the video number one so that you'll understand what I mean by reflection. Reflection is like there are two properties like say suppose this is point 3 comma 4 when it reflects under x-axis it will take perpendicular bisector between that mirror image or mirror line. Are you getting it? So then we're going to get the reflection. Now what do you mean by reflection under origin? Simple. We will have to draw the line which will go somewhere here and we're going to place it over here, the reflection, isn't it? So 3 comma 4, it will going to reflect as minus 3 comma minus 4. That is the reflection of point A under origin. So if we'll draw that perpendicular, we're going to get over here something like as perpendicular, like, the perpendicular will going to be something like this, isn't it? So I hope you understood what I mean by properties of the reflection. It is perpendicular and bisecting. Okay. And now what is the reflection of this point A under origin? It will going to become A prime or A triple prime भी बोल सकते हैं minus 3 comma minus 4. So what do we understand? Both the coordinates get reversed. What do you mean by that and how to write it on that? Say A 3 comma 4 when it reflects under origin, okay, mirror image under origin, it becomes a triple dash as minus 3 comma minus 4. So how are we going to formulate it? When a x comma y when it reflects under origin, when it reflects under origin. Okay, what do you mean by origin? Okay, some people are asking what is origin, sir. So origin is this. Okay, could you see over here origin? Origin is called as 0 comma 0, where both the axes meet each other. You got it? So that is called as origin. So when any point reflects under origin, both its coordinates will get reversed. So a triple dash will become minus x comma minus y. I hope you understood what is this reflection under origin. Okay, so any example, if you want to do more example, like say this was example number one, this is example number two. Say B is 5 comma 6. So what will be the reflection? B triple dash under origin will going to become minus 5. Very nice, perfect. That's perfect. Some people shouted minus 5 minus 6, isn't it? Too good. So suppose at any point like 5 comma, okay, minus 5 comma 2, if this is the point and we're reflecting under origin, what will happen? Reflection under origin. So simple, it will become C triple dash. Some people are wondering why triple dash, because in it's just a nothing called a standard notation. I thought for x-axis I took C prime, or for a y-axis we took C double prime. So for origin we're taking C triple prime, nothing like that. So it will become 5 comma minus 2. Just reverse both the things or both the coordinates, isn't it? So simple. I hope you understood what do you mean by reflection under origin. So if you're not finished, you can pause the video over here and copy paste this quickly in your book. Hurry up, guys. Now we're learning something called as double reflection. What do you mean by double reflection? So what do you mean by double reflection? Say suppose this is point 3 comma 4 A. Okay. It looks like 8 comma 4, but it is seriously 3 comma 4. Okay, so 3 comma 4, when first of all it reflects under x-axis, it becomes this. When it reflects under x-axis, it becomes a prime. as minus 3 comma 4, and after that it becomes or it reflects under y-axis. Let's say it reflects under y-axis, so it will become minus 3 comma minus 4, isn't it? So they ask what is this. Okay, this is written as a double dash. So what is single transformation? What is a single transformation between these two things? That is what their question is. So, what is double reflection or what is single reflection? I hope you understood the question. So, the question goes always like this way. You understood? I, I hope you understood what I mean. I mean to say. Say it looks something like this. One second, I'll just reflect it. Just rotate it. So, I mean, one second. Hold on. So, what do you mean by single reflection or what do you mean by double reflection? I hope you understood. Okay, what do you mean by okay? So A is 3 comma 4 when it reflects under x-axis, it comes to A prime. Please keep writing, guys, as minus 3 comma 4, and when it reflects under y-axis, y-axis, it becomes a double prime. It becomes a double prime. So that becomes minus 3 comma minus 4. So what is the single transformation between a to a double prime? A 3 comma 4 to a double prime. What is the single transformation? Can you guess? Simple. When both the coordinates changes, like x becomes negative, y also become negative, so it is reflection under origin. So guys, what is the trick over here? Remember that if you are done with x and origin, then the remaining would be y. If you are done with x and origin, then the remaining would be y. Or if you're done with y and origin, the remaining would be x. So the single transformation is always the remaining one. You can remember that way. Or else you can actually go on the graph paper and you can do like it reflects under origin and then under y-axis. So the single transformation is under x-axis. If it goes first of all origin and then x-axis, the single transformation would be under y-axis, like that way. You understood? So the single transformation you can remember that as the remaining one. I hope you understood what I mean by. So ये जो double reflection है या फिर single reflection है, I hope you understood. So why it called as double reflection? First of all, it reflects under x-axis and then it reflects under y-axis. So it is called as double reflection. Or else some people call it single reflection also, like A to A double prime. What is a single reflection? So you should understand this question. Don't worry, guys. We're going to do many questions based on that, and then you will understand this is perfectly. So I hope you finished writing till here. If not, you can pause the video and copy paste this. I hope you finish double reflection or else single reflection. Why I use this double reflection and single reflection, guys, I hope you understood. So some people call it double reflection, some people call it, some teachers call it single reflection, but the concept is same thing. So if you're done with X and then Y, so the single reflection will become origin. If it's done with Y and then origin, then the single reflection would be X-axis. If you're done with say X-axis and then origin, the single reflection would be Y-axis. Irrespective of the cases, so this is how you can remember. Whatever is the remaining, that is a single reflection. If X and Y are done, then origin is remaining, so single reflection will be origin. Let's move ahead, guys, with the next concept, something called as um, invariant point. What do you mean by invariant point? Invariant points. Keep writing, guys. Keep writing. What do you mean by invariant points? So invariant points is after reflection they do not change. What do you mean by invariant points? After reflection they do not change. What do you mean by that? They do not change. Think. Can you think? What do you mean by they do not change means what exactly happened? Say after reflection they do not change. Like we have got this point 4 comma 0. What is this point? A is 4 comma 0. Try reflecting it under x-axis. 4 comma 0, when it reflects under x-axis, it will not going to change because it is on the mirror line, or it is on the mirror line, sorry. It is on the mirror line, isn't it? So when point do not change after reflection, it is called as invariant point. When point do not change its position after reflection. Keep writing. When Keep writing in the top margin. What is invariant point? When point do not change, do not do not change its position. When do, when point do not change its position after reflection. That is called as invariant point, or that point is called as invariant point. I hope you understood. When the point do not change its position after reflection, that particular point is called as invariant point. Now, every point which lie on the x-axis is invariant under the x-axis. Keep writing down. Keep writing, guys. Every point on the x-axis, every point, keep writing. Every point on x-axis, every point on the x-axis is invariant under x-axis, or reflection under x-axis. Reflection under x-axis. Same thing. You can say that the same sentence you can copy paste. Okay, I'm just copy pasting. You can just copy paste it. Okay, copy and paste. So what is this? Every point. Okay, I'll just copy paste it 2 times. You'll understand the funny part now. So every point, a reflection under y-axis is okay. Every point on the y-axis. Every point on the y-axis is invariant reflection under y-axis. Every point on the not on x-axis. Every point on the origin. Okay, you can say origin. You can say origin, not every point. Origin is invariant reflection under origin. Okay, I can just reflect the sentence. Origin is invariant reflection under origin, or x-axis or y-axis, because it is like the common point between x-axis and y-axis. So origin is invariant under everything. Origin, x-axis, and y-axis. I hope you understood all these three sentences, isn't it? Now I guess I am done with all the concept of this particular chapter. I hope you understood everything. If you're finished writing, it's well and good. If you're not finished, you can pause the video and copy paste it quickly in your book, guys. Okay? So this is what we did right from the beginning onwards. Now we will do few sums based on this concept. Reflection under x-axis, under y-axis, under origin, double reflection or single reflection, and what is the invariant point. That's all. That's all the concept, guys. And now the four marker, one standard question is always I have seen in your board paper, guys. So how to do that? Let's start doing that question. Then you'll understand on that. Okay. Okay, students. Now understand, guys. What happened? Use the graph paper. What happened exactly when we have to do this sum? So read your question very carefully and make sure that you solve the question 2 times. One with the sequence of the exam, and second one on the graph paper. Why? Because sometimes what happens, students, when they are in the flow of corrections, they forget to go on the graph paper, and then there you lose out your marks. Or sometimes they give you marks on that graph paper, and then they forget to give over here in the main sheet, and then that's how it becomes a loss. So I always recommend all my students write it down this question 2 times. Just चार लाइक extra लिखने में कुछ भी problem नहीं होता है, isn't it? So try to solve this question always 2 times in your examination. One in the graph paper and one in the sequence. One. What is the question? Use the graph paper for the question. The point 5 comma 3 is reflected in the origin to get the point P dash. What is the coordinates of P? So how to do this? First part. When point P 5 comma 3 reflects under origin, what happened? It will become P dash. So when it reflects under x-axis, I mean origin, both the coordinates changes. So minus 5 comma minus 3. We're done with the first part of the sum. Guys, we'll have to do this in the on the graph paper. For time being, I'm just solving it over here. And then once I'm done, we will go on the graph paper. N is the foot of the perpendicular from point P to the x-axis. Find the coordinates of N. Okay, the coordinates of N हमको यहाँ पर ढूंढने पड़ेंगे. Okay, what are the coordinates of N? We'll have to just write down the x coordinate and the y coordinate. Hold on. We will just N is the foot of the perpendicular of P dash to the x-axis. Find the coordinate of N. So that would be our third step. One second. One second. We'll just go on the graph paper and then we'll do that. Name the figure P M P dash N and find the area of the figure P M P dash P prime N. How to do this question? So for this question, guys, we need graph paper. Just hold on, pause the video, copy paste this, and meanwhile I'm just drawing the graph. I hope my graph paper is ready over here. Point P is 5 comma 3. So where will be point 5 comma 3? Here will be the point P. 5 on the x-axis and 3 on the y-axis. Point P is 5 comma 3. Now from there, what is the second part of the sum? Read it. If N is the foot of the perpendicular from point P to the x-axis. If we draw perpendicular, if we draw the perpendicular line from point P to the x-axis, it is going to look something like this, isn't it? Now, what are these coordinates of point M? So this is PM is like the perpendicular. So what is this coordinates of M? M will going to be, okay, generally the coordinates are written with the three lines, okay? M is 5 comma 0. X-axis would be 5 and the y-axis would be 0. Y coordinate would be 0. And then there is point N. When it reflects under point origin, it becomes minus 5 comma minus 3. So this becomes P prime, isn't it? So minus 5 comma minus 3. And if we draw the perpendicular of this point to on the x-axis, it comes like this. This is perpendicular, isn't it? And this is point N. So what are the coordinates of N, guys? Now guess what are the coordinates of N? Coordinates of N will become minus 5 comma 0. Minus 5 comma 0. I hope you understood that. Minus 5 comma 0. Because it's on the x-axis, minus 5 will come and the y coordinate will be 0. And now if you just join these 2 points, what is the name of this figure? What is the name of this figure is? See, the opposite sides are parallel. Opposite sides are parallel and then they are equal actually. This is also 3 and this is also 3, isn't it? So when the one pair of the opposite side is equal and parallel, the quadrilateral PMP dash N, PMP dash N, okay, PMP dash N is parallelogram. So what is the name of the quadrilateral? Parallelogram. I hope you understood this. Okay, one second, I'll just copy paste this over there up. So you can copy paste like this. Right? Did you understand? This was the graph work. Copy, I'm copying and pasting it over here. Paste. See, I'm pasting it over here. And I'm again copying this and pasting it there. Copy and paste. So I'm pasting this coordinates of N over here. You understood what I was trying to tell you? So आपको ये question दो बार करना है. कैसे दो बार करना है? I hope you understood that. Why you have to do this 2 times? I hope you understood. Why you have to do this 2 times? Because one, when wherever the sequence is there of the question, and second one on the graph paper. जैसे मैं यहाँ पर sequence में कर रहा हूँ, and then I'm doing it on the graph paper also simultaneously, isn't it? Whenever you're doing it on this graph, please make sure that you write the scale and the question number very carefully. Scale will become on both axes. On both axes, 1 centimeter is equals to 1 unit. If you have no scale, you will not get full marks. That's the reason scale लिखना बहुत जरूरी है. Next, I guess we finished the second subpart. What is the coordinates of n? We're done. What is the coordinates of n? We're done with that too. What is the name of this figure Pm? We finished that also. Name of the figure Pm P dash n is parallelogram. And now the last part. Find the area of this figure Pm P dash n. Now how to find the area? So look at this. So there are several ways to calculate. So the base is over here. Okay, base into height is like the basically. So the base is 3 and the height is 10. The height is 10 units. So what is the area? Area of parallelogram. Oh, if you're not understanding how to do that, you can do another way as well. So there are two triangles. Triangle PMN, we can find the area of this triangle, isn't it? And plus you can find the area of this triangle MNP. Are you understanding? MNP is this, isn't it? This triangle. And you can find the area of these two triangle and you can add that. That's how you can get the area of this total parallelogram also. But you can directly also do. So that was fourth subpart, and the fifth subpart is area of PM P dash N, which is equals to base into height. So base is 3 and the height is 10. So the area is 30 unit square. Please keep writing the units so that you will get the full marks. I hope you are getting this. Isn't it perfectly done? So whole sum is on one screenshot. Then pause the video here and copy paste quickly. I hope why the height is 3 or why the height is 10. You can you can think that. Okay. So if you do the triangle method, it will become 3 into half into 10. And again, 3 is the height over here, half into 10 करेंगे. We're going to get the area of this green and red triangle, which is the same as the half and half will add up. It will become 1 times. Isn't it? Same thing, simple. Chalo guys, it's time to do move ahead with the next sum. But I guess in the next video we'll do 2 to 3 more sums, and we will do one very important concept, guys. What happens when point reflects under a particular line or any given equation of line? And there is one standard formula for that, which I'll give or talk or discuss in video number 3. So see you in the video number 3, how to find the reflection of any point under a specific line and how to do sums based on that. I hope you understood till here everything perfectly and you enjoyed watching this video. Thank you. See you soon in the next video. Till then, bye bye.